Okay, the next kind of equation we're going to look at, the next kind of function we're going to look at is what kind of function is this? Yes, it's a rational function because here we're dividing by x. Okay, so let's think about this for a minute. We want to state the x-intercepts. The x-intercepts are always going to happen when y equals to 0. Now let's think about, we were talking about fractions before. So how do I make a fraction? If I have a fraction, a over b, how do I make the fraction equal to 0? What about the fraction has to equal 0 in order for the whole fraction to equal 0? Actually, the numerator. So in this case, a would have to equal 0. If you have a divided by b and it equals undefined, what about the fraction is 0? Yes, so in this case, b equals 0. So if you have 0 divided by a number, you're always going to get 0. And if you have a number divided by 0, you will always get undefined. And that's really important to know with these rational functions. So look at my numerator right now. My numerator is 8. If I want to set 8 over x equal to 0, can I make 8 equal to 0? No. 8 does not equal 0, so therefore there are no x-intercepts, or you could say none. Okay? Because that would be when y equals 0. So when the whole fraction equals 0, you would have an x-intercept. That means you're going to set the numerator equal to 0. For the y-intercept, we would set what's true on the y-axis. We would set x equal to 0. That's what we did in the last two examples. So state the y-intercept. When I set y equal to 0, what happens? Or I'm sorry, when I set x equal to 0, what would happen? Yeah, I would get 8 over x, or 8 over 0 equals undefined. So therefore, there are no y-intercepts either. Intercepts. Okay? Because a fraction equals 0 if and only if the numerator equals 0, but not if the denominator equals 0. So what do you think the domain of the function is? And we've been talking about this restriction on the domain. What number the domain refers to the x values, right? That's what the domain refers to. What values of x can you not use? You can't use 0. So you have x such that x cannot equal 0. This right here is called set builder notation. Different than interval notation, but it means essentially the same thing. It means you can use any value of x you want, but you cannot use 0. Okay, now what about the range? Well, let's start to look at the graph before we get to the range. So if I want to create any kind of graph, I can use a table of values. Because x is the independent variable, I can choose whatever values of x that I want. Maybe I will choose -8, -4, -2, -1, 0, 1, 2, 4, and 8. Why did I pick those particular numbers, do you think? Why didn't I want to divide by like 8 by 5, for instance? Yeah, it doesn't go in evenly. I'm going to get a decimal, I'll get a fraction, okay? So let's go ahead and plug in these numbers. If I plug in -8 for x, I'm going to get f of -8. What's 8 divided by -8? Yes. What about -4? Will it give me? Yeah. 8 divided by -2 is? And 8 divided by -1 is? Good. I can't actually divide by 0, can I? So if I did divide by 0, I would have undefined. And on your calculator, if you plug this in to get the table of values, you would see that you would get an error there. What about 8 divided by 1? 8 divided by 2? 8 divided by 4? 8 divided by 8? 1. Okay, so if I want to plot these points, I have -8, -1 is here, and you could plot and label those. -4, -2 is here. -2, -4 is here. And -1, -8 is here. So what I'm getting is like this curve shape right here. And what's going to happen is we're going to learn about asymptotes. So you're not able to use x is equal to 0. And so your graph is actually going to get very, very, very close, because if you kept plugging in numbers for x, like, I don't know, -1/2, then you would end up getting -16. But I'll show you that on the calculator in just a moment. Let's graph the other side. 1/8, 2/4, 4/2, and 1/8. And so then we see this side. Now, what's going to happen too, as x gets really, really, really big, let's say you went 8 divided by 16. What's that going to be? Oops, not 1/12, 1/2. Okay. What if you did 8 divided by 64? That's actually going to be 1/8. Okay, and so you're going to be seeing that as x goes to infinity, as x gets really, really big, you're never going to be able to get to 0, because every time you divide x by a number, since you have no x-intercept, remember how we said it would never cross the x-axis? What's the range going to be then? What y values are you going to see? Yeah, you're going to have the same exact situation. Y such that y cannot equal 0. So it's going to avoid that x-axis. You're never able to make the fraction, because every time you divide 8 by a number, no matter how big, how small, you can never make that number into 0. Okay, what questions do you have now? Yes. You could use interval notation here, and the way that would look is from -infinity to 0. Oh, here's an example of where you would not include 0, right? You would not include 0 because you're trying to avoid it. This right here is a symbol that means union. So it could be or 0 to infinity. So that's the answer to that question. When will you not include the number? Right now, we're not going to include y equals 0. So we would go from -infinity to 0, and then we would go from 0 to infinity, and we would not include 0. See how that's jumping over? And this one right here is called interval notation. Any other questions on this? Did you have another question?